Hello everyone, my name is Jennifer Romatelli and we are here at the Sims Hall of Science at Roper Mountain Science Center. We're going to be talking about Newton's first law of motion, which is also known as the law of inertia. Basically says that an object at rest tends to stay at rest, an object in motion tends to continue moving. So either way, things continue doing what they're already doing unless acted on by an outside force. And depending on how much inertia they have, that outside force may or may not be able to make them change their motion. So I have here a stack of empty plastic buckets. They are separated by just some ordinary cardstock sitting on top of a tablecloth on a smooth table. I'm going to try and pull this tablecloth out from under the buckets, and we're going to see if their inertia, which right now they're at rest, if that is strong enough to overcome the force that I am adding. So then try this in 3, 2, 1. Now, as you can see, the inertia was not strong enough to overcome the force that I added. So in this case, we caused some motion. There's two things that affected the result. One is the amount of friction that we had between this tablecloth and the bucket that was sitting on top of the tablecloth. And the other thing, of course, was the inertia of our stack of buckets. So if we want to do this again and hopefully succeed in pulling the tablecloth out with the buckets staying put, we can change either or both of those things. First, we can try and reduce the friction. Now, this tablecloth is made of felt. It's very fuzzy and soft, so it creates a lot of friction with objects that rub on it. If we were to use a much smoother tablecloth, which I have here, we'll have much less friction between the tablecloth and the bucket. So we'll set this one up. And then to change the inertia, we want to increase the inertia of the buckets. Think about what property of our stack of buckets we could change in order to increase that inertia. I'm hoping you're thinking to yourself, we need to increase the mass. So that's what we're going to do. You want to do that, there's a lot of ways we could, but you want to do that with something that's not going to make a mess or break. So we're going to use these bean bags. And I'm going to put them in the bottom bucket. The reason for that is this is the bucket that we most want to stay put. If everything on top of it is connected to this one, then if this one stays still, everything else should also. Stack everything up again. The last one over here. And see if we get a different result. In 3, 2, 1, and voila. So that time inertia overcame the force applied to it, and our stack stayed put. I encourage you to try this on your own at home. Of course, make sure you have permission for any materials that you use, and use materials that are both non-breakable and not likely to damage anything that they fall on. Change up the way that you try it and see what happens. Practice it and see if you can impress your friends. I hope you all enjoyed learning about Newton's first law. Roper Mountain out.